During the normal flow of execution of a program, errors occur. When an error does occur, there are some things to consider. First, it's usually pointless for a program to continue with its current task. It could be that a file didn't open for some reason, that a calculation has gone wrong, or some object is simply missing, or any one of dozens of other things could have happened. In almost every case, continuing the process will only result in making things worse. The error needs to be reported. Even if it's possible for the program to continue in some way, the error needs to be reported so it can possibly be corrected and the program can be run again. If the program is forced to shut down because of the error, it's nice to tell the user what went wrong instead of just folding up and quitting. The program needs the opportunity of continuing or not continuing to process. The program may just continue from where the error occurred, or it may need to skip some things and try a different approach. Maybe the program just needs to tell the user what happened and wait for further direction. Whatever needs to be done, the program needs the opportunity of doing it. That's what exceptions do for you. When your program detects an error, it will immediately abandon what it's doing and handle the error. You can write your code to ignore the error condition and move on, or go to an entirely different location in the program and do something else entirely. You can even choose to report the error and halt the program, and for some errors, that's about all you can do. In Java, when an error of some sort occurs, you create an object that contains a description of the error, and then use the throw command to cause the process to abandon its current activity and throw the exception object. Somewhere in the program, the thrown object is caught. It could be right at the point it's thrown, or it could be in the method that calls the one containing the throw statement. Or it could be several method calls up the calling chain. The important point is that once an exception is thrown, no other processing takes place until the exception is caught. Then execution continues from the point of the catch. The original block of code, the one that threw the exception, is abandoned entirely, and it's abandoned at the point the exception is thrown. Now, there's a definite procedure to be followed in throwing and catching exceptions, and there are even different kinds of exceptions, and some have to be handled in a special way. Now, the good news is that the compiler helps you in setting up your exceptions, so it's hard to mess up, really. For the most part, you can just code blindly on without paying any attention to it, and the compiler will let you know when you need to put in some code to handle the exceptions. The superclass Java Lang Throwable is the superclass of every object that can be thrown as an exception. Only objects of this class or subclasses of this class can be thrown by the Java throw statement. An object of this class contains some of the key information, such as a complete traceback that tells the receiver of the object where the object was thrown and how it got there. There are two kinds of exceptions thrown: checked and unchecked. The Java Lang Throwable class has two subclasses, error and exception. An object of this class, or one of its subclasses, is thrown for a serious problem. This type of exception is usually thrown by the system to indicate the death of a thread or something equally as fatal. These are also known as unchecked exceptions because the compiler doesn't check whether they could be thrown, and it doesn't require you to specify in your code that they could be thrown. Under normal circumstances, your program should not catch unchecked exceptions. They should be allowed to continue up through the method calling chain until they reach the virtual machine, at which point an error message is displayed and the program halts. In special circumstances, such as embedded systems that must keep running, you may want to catch these, but be sure you know what you're doing before you try to continue processing. The exceptions you will normally deal with are extensions of this class. They are the ones that you'll want to catch and do something about. These are known as the checked exceptions because if one is thrown, the compiler checks to make sure you have included the code to catch it and otherwise handle it properly. Not only must you catch it, but if you throw it from a method, you will have to declare that method as possibly throwing that exception. This class is sort of a special case. It's a subclass of the Java Lang exception class, but it is unchecked. That is, it's a special kind of exception that isn't checked by the compiler to make sure you catch it, but it is of a type that you might want to catch anyway. This one and its subclasses are thrown by the system for things like divide by zero and negative subscript values. They're definite system errors, but they're not fatal to the program. If this is all new to you and you're a little confused by the names, there's a reason for it. The names are confusing. Let me run through it right quick. All of these classes are throwables, no matter what their name, and they are all exceptions. The whole process is known as exception handling, no matter what class of the specific object is being thrown. Now, anything that's an extension of the error class is unchecked. Anything that's an extension of the exception class is checked, with the exception of the runtime exception class. Anything that is an extension of the runtime exception class is unchecked. And the name runtime exception is odd too, because all of these exceptions are thrown as a result of a runtime problem of some sort. But this is not the first, nor will it be the last time that you'll find naming confusion among things Java. They seem to have a talent for it. For example, there is a class named class, so you can have objects of the class class. And there is a class named object, so you can have objects of the object class. And the choice of the word import is terrible, because it doesn't actually import anything. I'll be getting to import later. It actually provides more than one type of confusion. I'll be showing you the mechanics involved in doing all this throwing and catching in the next couple of lessons.